Hello everyone, I hope you are doing well. So in this video, we're going to discuss the solutions for Codeforces round 818, which was rated for Division 2. So let us start with the first question. The first question says that we have to find the number of pairs A comma B, where both A and B are between 1 to n, and LCM of AB upon LC or upon GCD of AB is less than equal to 3. So first of all, we can reframe this sentence as LCM of AB is less than equal to 3 times GCD of A comma B, right? So this is what our question says, and both A and B should be between 1 to n, right? So if you observe carefully, then the obvious thing would be for every number A, or the only valid pairs for or the only valid options for B are A, the other option is A, then it is A plus A, and the third one is A plus 2A. So these are the only valid three pairs for every A, right? Now if you try to do A comma A plus 3A, then the LCM of A comma B would be greater than or equal to 3 times GCD of A comma B, because in this case the LCM would be this thing, right, and the GCD would be A. So if you multiply it with 3A, this side it will become 4A, and this side it will become 3A, which is obviously greater than, right? So these are the only three cases that are possible. So what we can do is we can find the numbers which have two multiples, right? For example, we have to find the number of A's such that A plus A and A plus 2A exists, right? How do we find these numbers? We can find it easily by doing n by 3. So these will be the numbers for which A plus A and A plus 2A will exist, and A plus 2A would be less than or equal to n, right? So this is the first part of our result, that is n by 3. So these n by 3 numbers will contribute to these, because it will be A plus A and A plus 2A, right? So we have to do this. These n by 3 numbers will contribute to two numbers or two pairs to the final answer, right? Now there will be some pairs for which only A plus A exists, right? There will be some pairs for which only A plus A exists and A plus 2A doesn't exist. So we can find it easily by doing n by 2, right? But unfortunately now what will happen is we have included A plus A in this number also, and we have included A plus A in this number also, right? So we have to subtract it once. So n by 2 minus n by 3. This will be the second part of our answer, right? And if you observe carefully, then if we have A comma A plus A, then A plus A comma A is also possible, right? So we will multiply this particular part by 2 and then finally add n, because A plus A is possible, and I didn't include it inside this bracket because A plus A, even if I swap these, it will still be A plus A comma A. So I have to add it separately in the result. So our final answer would be, we can further simplify it, because n by 3 into 2 is here and minus n by 3 is here. So we can write it as n by 2 plus n by 3. This would be multiplied by 2 and this whole would be added to n, right? So this would be our final answer. So this is exactly what I have done in the code. I have calculated n by 2 plus n by 3 multiplied by 2 and added n to the answer. So this would be the final answer for our question A. Now moving on to the second question. The second question says that there is a table of size n into n, where n is a multiple of k, and the table consists of either dots or crosses. So it is a table containing only these two characters, right? And we have to form a table such that among any k consecutive vertical or horizontal cells, there must be at least one character containing x, right? And we have been given a position, the position of at least one x. So the position of one x would be already given, and the question says that the x is definitely present at this particular position. We have to find the other number of x, position of other x is such that this condition is satisfied, that for every k consecutive vertical or horizontal cells there must be at least one x, right? So if you like just observe the pattern in the question itself, in the test cases itself, let me copy this. So we can take this particular test case. So this is the test case given in the question, and it says that 4 comma 2. It says that it is a grid of 6 comma 6 and the value of k is 3, and 4 comma 2 is the initial cell where x is present. So 4 comma 2 would be this particular position, right? So for every three or consecutive rows or three consecutive columns, there should be at least one x present, right? So what we can do is we can just directly go to 1, 2, 3. This row should have an x, right? And if we go left side, 1, 2, 3, 1, and then 2, and then 3. So this position should have an x, right? And similarly, we can form a pattern that one down and one left, then this particular position will have an x, then one down, one left, this position will have an x. But if you observe that these positions are outside the board, so we do not need to put an x here. We can just traverse through this particular row itself, and then for example, if we are at this particular dot, then we can go to this particular dot plus 3 columns. So it would be 1 here, 2 here, and 3 here. We have finally found we are finally inside the grid. So I have to put an x here. Then I go one down, one left. I put an x here. I go one down, one left. Again, it is out of the grid, so I don't have to put an x here, right? Again, from this particular position, I go 2, 3 times right. 1, 2, 3. I reach this particular position. I repeat the same procedure. One down, one left. One down, one left. One down, one left. One down, one left. Again, I have to put x in all these positions. Now, if I'm here, then again I go right 3 times, 1, 2, this is outside the board, and this is also outside the board. So these all blue dots are outside the board, and I'll show you how we can put the other x's here. So again, one down, one left, one down, one left, this is x, one down, one left, this is x, one down, one left, x, and similarly this one is also x. Right, so we can continue, keep on continue doing this, and we can form our final answer. So let me show you the code. It will be easier that way. And as you can see, I've taken all the inputs in n, k, x, and y, and I've declared n as a global variable. So I just do minus minus x and minus minus y for zero-based indexing, and then I form a board of characters of size n cross n, and I mark all of them as dots. Right. So now the x and y are the top and the left variable. I've stored them in the top and the left variables. So while top is greater than 0, I'll do top minus is equals to left. So I keep on doing this to find the top and the leftmost position, as I have done in this particular thing. So in this case, the top and leftmost position was this one. Right. First of all, I find this particular position. Then what I do is, while the left is less than 5n. So the reason why I did this was because even if you go, like for example, for this particular x, even if you go beyond this n, this nth column, there you will still have to go to find this particular x, because it will be present, the dot will be present somewhere here, which will eventually trace back to this particular x, right? And you have to go like 5 was just some arbitrary number I took, but one thing was for sure, that you have to go for greater than n, and 5 in this case passed all the pre-tests, right? And for every left, I initialize the x as top and y as left. So this is like the x will always be at this level, and y will be like, once while y is, for the first time y is here, then y is at this level, then y is at this level, like y will traverse like this. right? So at the end, what I can do is for every x and y, I can check if it is valid. I mark the board at x and y as x. So how do I check that it is valid? If x is less than 0 or x is greater than minus 1, n minus 1, and y is less than 0 or y is greater than n minus 1, in all these cases, if any of these is true, then I return 0, otherwise I'll return 1. This is how I check whether the current cell is valid or not. And I keep on doing plus plus x, move to the next row, and minus minus y to move to the left column, right? And after I have done this, I add k to the left. So again, first of all, y is here, then here, so it is incrementing by k every time, right? After I have done this, completed this loop, I just print the board. So this is how the second question can be solved, right? Moving on to the third and the final question for today's video. This particular question says that we have been given an array of integers, and in each operation what I can do is I can make ai equals to ai plus 1, right? And I can only do it if ai is less than equal to ai plus 1. So it says that this is a1, this is a1, this is a2, this is a3, this is a4. So I can set this particular number as ai plus 1 if currently ai is less than or equal to a2 plus 1. a1 is less than or equal to a2 plus 1, and for a4 it is a4 should be less than or equal to a1 plus 1, right? So it is a circular thing. So what we can do is, what we have to do, we have been given some numbers b1, b2, b3 and b4. So our task is to make both of these arrays equal, and we have to tell whether we can make both of them equal or not. So this is the question, and let us consider an example. What from the test cases, it is 1, 2, 3, 4, 5 and 6, 5, 6, 6, 7, 6. So we in each operation, if you observe that, then we can add 1 to any element. So obviously, if the ith element of array A is greater than the ith element of array B, for example, like this, so this is AI and this is BI, then the answer would be straight away no, because this is never possible. We cannot convert 7 into 5. So this is our very first claim. Now the second thing is, I have to increase, for example, I have to increase this particular number, right? I have to make it to equal to 6. Then this particular number should be at least be equal to 5, because when both are 5, then I can make this 6 by doing plus 1, because they both are equal, right? So this particular number should be able to reach at least 5. So for example, if the target for this particular number is t, then the next number should be at least be able to reach t minus 1. So if the limit of the next number is less than t minus 1, then we cannot form an answer. And how do we find our limit? This is the limit, because the second element can at max reach 5. So for example, I want to make 6 at this position, right? So I can make this particular number 6 only if this number can be at least 5 or greater than 5. This number can be 5, so this is okay, right? So I have to make this number 5. So this particular number, which is right now 3, should be able to reach at least 5, at least 4, because when both are 4, I can increment this particular number and make it 5, right? So this particular number should be at least 4, but it can reach up to 6. So this thing is also good, right? Again, if I have to make this number 7, then this particular number should be at least 6, and this particular number can achieve 6. So this is also okay, right? So we keep on doing this, and for this particular number we check from the first element. So this is what I have done exactly in the code. I've taken two vectors as input, and what I do is, for every number at the ith position, I set the target equals to b of I, right? So if the target is itself less than the ith element that is stored in a of I, then the answer would be straight away no, and I just return, right? And I find the next index as I plus 1 mod n, because for the last element the next index would be 0, right? So if the target if the current element is less than target, that means we need to add something to the current element, and the bth element of b, the next index is less than target minus 1, which means that, for example, if I'm considering these two numbers 1 2 and 6 5, so I'm comparing this particular target which is stored in b of I, I'm comparing it with this particular number, right? So if that is defined it as x and y, so if x, so if y is less than x minus 1, then the answer would be no, because I can, if as I've already told, that if this particular number right here, for example, it is 4, then I cannot make this particular number equal to 6. Either it should be already 6, then it is fine, but if it is not already 6 and I need to increase it, then I cannot increase it, because this would be at max 4, right? And that case 6 would be greater, and in that case I can at max make it 5, because at this point 5 would be greater than 4, right? So I can never make this first number equal to 6. So in this case I can just print no and return. So if none of the cases fail, then I can just print yes at the end and print my final answer. So this is how you could solve the third question, and I hope you guys were able to understand the solutions. So till the next video drops, keep coding, stay safe, bye bye.